So in this question, we're going to use the SAMS Unit 2 question. Again, it's a connected particles question. We just have to look through the context and set up our system of connected particles. Now, this is a situation where we have a horizontal plane on which a truck of mass 180 kilogram rests. Then we have the light and extensible rope going over the smooth pulley down a shaft to which a load of m kilograms is attached. And what we want to find out is what's that value of m going to be for the truck to be able to move with an acceleration of 0.8 meters per second every second. In part B, it wants you to talk about some of the assumptions that you've made. So in the first instance, what we've got is our very simple connected particles over horizontal and vertical. So if I add in my detail now, well, my mass of my truck is 180 kilograms, so we have 180 G acting straight downwards. We have a reaction force of 180 G as per Newton's laws, equal and opposite reaction. But what we have happening in the horizontal is absolutely no resistive force because we are on smooth horizontal rails, so there is nothing happening to resist the motion of that 180 kilogram truck. Then we obviously have our mass of m kilograms, which will result in a weight of mg acting downwards. The tension we don't know, but we know because the string is light and extensible, the tensions will remain the same throughout. And the acceleration of this system is 0.8 ms to the minus 2. And again, because it's a light, inextensible string, we are having the same acceleration across both sides of the pulley. Now, as in previous examples, we just apply F equals ma to both systems. So I'll call the truck A and the mass B. So if I apply F equals ma to our first situation, which is A in the direction of motion, we'll have T minus 0 is equal to ma, which is 180 times 0.8. So immediately we can calculate the tension in the rope as being 144 newtons. So now we know that tension is 144. That then helps us when we apply this F equals ma to B, and the direction of motion in this case is downwards. So now we can say, well, that mg minus tension, which is 144, is equal to ma, which is not m times 0.8 or 0.8 m. If I just write that m the same as the other m, so we know that they're one and the same. It's a good plan to do in the exam. So then a bit of rearrangement, we've got mg minus 0.8 m is equal to 144. Now obviously taking gravity to be 9.8 as it says on the front of the paper, we're then left with 9m is 144, so m would be 16 kilograms. Remember, this is a mass. So that's the mass required to move the truck at 0.8 meters per second every second. Now, obviously it asks about modelling assumptions. Well, the first one would be, in a perfect world, we wouldn't have smooth rails, would we? So there would be a resistive force. That would mean then that we'd have a T minus something, so our tension in the rope would go up, because as the resistive force increases, the tension would increase. We can also talk about our light inextensible string, as we've talked about before, keeping tension constant across the system, so we can compare both elements of the mass and the truck, and the pulley being smooth again keeps tension constant, and the inextensibility of the string. All these things